Thank you. Can you see? Yeah, you can see it now. So my name is Ákos Izsó, as I was just introduced, and I'm going to talk to you about how we sell seats and push pints at our live entertainment company, AEG Europe. When I tell people that I work for AEG, they usually ask, oh, the insurance company. So no, AEG is not an insurance company. Then they ask that, okay, so you're doing washing machines and dishwashers. No, we don't do that neither. AEG is the world's leading sports and live entertainment company. It entertains over 100 million fans every single year. It's the second largest music promoter on earth. It promotes concerts and tours for artists like the Rolling Stones or Elton John or Justin Bieber or Katy Perry and many others. It promotes over 10,000 shows and concerts and festivals each and every year. It pulls together festivals like the Barclaycard Card Present British Summertime Festival in Hyde Park in London, UK, or in Los Angeles, California, the Coachella Valley Arts and Music Festival. It also owns more than 115 venues across 5 continents. So these are all big and huge arenas or convention centers. In Europe, it has operations in France, Sweden, Germany, and the United Kingdom. In the UK, it focuses in London. It runs the 12,000 seat capacity SSE Wembley Arena, and also owns and manages the 20,000 seat the O2 Arena, which has been the world's busiest venue since it opened its doors 10 years ago. So let's try to understand that how data can really support the business of AEG. So to be able to see that how data plays into the story, we need to understand on a very high level what are the business objectives at AEG. Well, for the promoters, it's quite simple or quite straightforward if I simplify it. They want to put together great shows that sell out, world-class productions that are going to sell all the tickets. So with the help of data, we can target our fans and find the right audiences for each and every show. For the venues, it's also great if we can put together and host great events that sell out. But from a revenue perspective, for the venues, what is even more important, if they can sell their premium products, such as premium seats with table service or like lounge access before the show starts. Again, with the help of data and reaching out directly to people, we can target the right audiences to buy these products. And from a revenue income perspective, what is even more important is to please our fans and really serve them best needs in terms of food and beverage offers we have on site. So when they come and see a great night, they really make a big night out and drink a lot. So the idea here that data can really help fulfill this objective by predicting demand. Because if we understand the demand, that who is coming and what they're going to consume when they come, then we can just tailor the offers to their needs, to the audience's demand. So these are the 2 big things I'm going to talk you about. First, I will start with how we sell the seats with the help of data and analytics, and then in the second half, I'm going to move on to pushing pints. So let's start with selling seats. Just a quite high-level brief introduction. Well, we tailor our offers to lifestyle and preference, music preference to our fans. And we do this with performer propensity models and lifestyle propensity models. The performer propensity models identify the characteristics of ticket purchasers and picks the right fans for each and every performance and upcoming show. While the lifestyle propensity models are designed to identify the traits of premium ticket purchasers, premium product purchasers, and then just finds the right target groups who should be targeted with this product. It's all a closed loop, fully automated. The models run fully automated, and all email sent and push messages and communication on social channels are fully automated. The whole process runs without any manual human input. Let's see how that really works and how it all comes together. One of the first questions I'm usually asked that, hey, this sounds great, but so you do these models and you send these emails and it's all automated, but first of all, what sort of data, guys, you can work with? What data is available about your fans? Well, we know quite a lot, luckily, about our fan base and our audiences. First of all, most importantly, we know their purchase history. So what sort of shows they went previously, what sort of artists they watched previously. And also, we have demographics and lifestyle information about them through a third-party data provider. But most importantly, we have a lot of digital interactions, digital records of what they do online. And this is the behavior data. This is clearly reflecting preference, what sort of artists, genres they really like. So digital interactions like the email clicks, so what sort of artists they clicked through in our emails previously. The web views, whereabouts on our websites they browsed, which artists, which shows they showed interest in. Competitions, registrations, did they participate in any of the competitions to win tickets? Or did they register for pre-sale tickets? Well, that's a quite clear indication of music preference. App usage, where they tapped around in our apps, in our venue apps. And even more importantly, whether they ordered F&B, food and beverage products, so just order the beer through the app, or some merchandise, some T-shirts, on a given night. Because even if they didn't purchase tickets, but they used the app to purchase some products on site, then we can be sure that they attended the event on that night. That's really great to capture those who didn't actually purchase the ticket, but probably the friend or partner purchased the ticket for them. Same with the Wi-Fi connection. We have a public Wi-Fi in the arena, so if someone connects on that, we know that on that night they were present and they watched the show. And we have also Facebook likes, so for those who gave their consent and shared their Facebook page likes with us. This is a really rich and dense data set, and there are many ways we can leverage this. One of the great concepts is to calculate similar performers. So just looking at the interactions, what are the performers that can be deemed similar? So like Katy Perry is similar to Adele, let's say. How we can calculate that using our interaction data? Well, we do this in 3 simple steps. First, we create a fan performer matrix. So this matrix just has all the fans in the rows and all the artists in the columns, and there is a 1 if there's an association between a fan and the performer, and 0 otherwise. The next step, we just have to sum up that those fans who had some interactions with performer A, how many of those had interactions with performer B2? So for example, 50 Cent and Adele, 9,000 sharing 9,400 fans in this example here. This is already really good because it's quite clear that if 2 performers share many fans, then those can be deemed as similar. The only problem with this is that this has a volume or popularity problem. There are some shows an artist just way more popular than others. So Adele, in this case, had plenty more played out shows in our venues than 50 Cent, for example. So in a way, Adele is going to be similar to many of others who are actually not related necessarily. So to get around this volume problem, we calculate something called log likelihood ratio. Well, this is essentially just takes into account not just the relationship between shared purchasers between performer A and B, but also compares it to the shared number with other performers. So this gives us a weighted or relative number, and by calculating this ratio, we get a measure and a list of similar artists that focuses on distinctiveness rather than the popularity simply. So just in 3 simple steps, we get similar list of similar performers. So for example, Katy Perry is similar to Britney Spears, Lady Gaga, Beyoncé, Madonna, Adele, and so on and so forth. We can even just take all these similar artists in the matrix and run some clustering, and we arrive to these colorful branches of this image or illustration here. So clusters of similar artists, just to translate that into plain English, that means genres and subgenres of artists. So, for example, this one here could be probably called the pop divas. So both these similar artists and these synthetically calculated or algorithmically calculated genres come really handy when we build our models. So going back to the models, how we target based on performance, propensity, or fans. It's really handy to define the universes and to calculate variables. Because when we're talking about the performer propensity models, I'm going to start with that on the left. When we talk about performer propensity models, it's quite simple questions. Who are the most likely fans who will buy a ticket for an upcoming show? And we can answer that by looking at everyone who purchased tickets so far versus everyone else who had some interactions recently with a similar artist. And this is when similar artist concept is really useful, because we got millions of customer records. So if you have like 300 Wolf Alice ticket purchasers, you can't really compare that to 3 million other fans. The models wouldn't really deal with that sort of tilt. So we can just take the similar, those who interacted with similar artists. And the great with this is that it is already a really good target group. So almost everyone could be targeted, right? Because they are into similar stuff than this upcoming show. But we don't want to do that. We want to be more precise and more granular. So we run logistic regression models to identify the characteristics of purchasers and to be able to determine that who are the most likely to purchase tickets for the upcoming show. We have about, when I say characteristics, we have about like 200 input variables in the models. These are, as I said, like the web views of similar artists. So again, the similar artist concept plays into this. The email clicks in genre and similar genres, or previous attendance in similar genres. When we got these models, usually there are about like 90 are built each and every week, just picking it up, what open tickets are available for what shows. So when these models are built, we got really good target group for that, usually between 90 and 100 upcoming shows who are the most likely to buy tickets for those shows. And we can combine these on the right with the lifestyle propensity models, which are very similar in the concept. It tries to answer the question that who are the most likely to buy premium products or lounge access. We take the past purchasers of these premium products and compare it to a wider set of customers who were recently active. Obviously, have now a quite wide audience who already purchased premium products previously, so we can go with a wider model set here. We use logistic regression models again. There are 390 variables going into the models. These are the previously mentioned demographic and lifestyle variables that go into the model as well. But we have like lifestyle interaction variables. So if someone clicked on one of our restaurants in the next to the arena, so like Five Guys, maybe that's a good indicator buying these tickets. Or they connected to the Wi-Fi at TGI Friday. They spend there 2 hours. Maybe that's again a good indicator. So these are all fed into the models, and we get a really good target group at the end of customers who are very likely to purchase premium products. So we can combine these two concepts: the target group who are likely to buy tickets for an upcoming show, plus the lifestyle likelihood. And the email sends, push notifications are fully automated. Emails are sent out on weekends. It's, everything is just, there's a template and gets populated with the event details and creatives and images through the web API, and the emails are pushed out automatically. So let's see what are the results on the email channel for this communication. With blue, you can see the tailored communication, and with pink, just general sense like newsletters or some random marketing solutions. So for open rate, for the targeted, for the tailored targeted emails, we have a 33% so open rate. So that's 1 in every 3 person opens the emails. This is about 2.5 times higher than the general send. We have about 9 times higher click-through rate. The order rate is about 5 times higher, and the unsubscribe rate is just about half. So if you look at, it's great. The order is great, so we're selling lots of tickets. But if you also look at the engagement metrics, it's quite clear that our fans are just, find this less intrusive. They definitely not annoyed by these emails. That's reflected in a really low unsubscribe rate. And they, we definitely, target them with the right email, which is clearly come through with from the 1 opens it from 3 customer rate. Probably you're surprised that these are quite high numbers. So I don't know, there are other industries which probably, if you ever came across with email metrics, so these are really high numbers. But this is a live entertainment business. So people are really, they are interested. They want to see their favorite stars to perform at the O2 Arena. So it's a very fortunate industry, I would say. So to sum up, I mean, this is great since we, great engagement metrics and good order rates. So since we started this automated process, we sold over tens of thousands of tickets at virtually no cost. So this is pretty good on a channel which is effectively just an automated robot. So we are really happy with these results. Now let's move on from selling seats to pushing pints. So it's great that we already sold the tickets. They're gonna come have their big night out. How we can make sure that they're gonna find their favorite products at the bars. So how we push pints. As I mentioned in the introduction, here the idea is quite simple. If we understand the demand in advance, then we can tailor our offers night by night. When I say tailor our offers and our product offering, and the whole operation tailored by night, I mean different things. So tailoring the menu to the demand. So, we can swap around. Want to sell 3 different types of beers or 2 different types of ciders instead? Find the right product combinations. Should we package up hot dogs with beer or probably with cider? You can send out a targeted pre-event communication through push notifications or on email channels. So there's an early bird on white wine, and we don't say beer because we know that it's going to be a white wine audience. And we can even tune the displays, the digital displays throughout the night. So each of the displays are tailored, can be tailored and fine-tuned. What are the messages and communications we display there? And also very important, optimizing the stuff. So from an operational perspective, should everyone stand behind the beer taps, or it's better to send around people on the concourse and selling popcorn or ice cream? So this can be all understood better with precise demand prediction. So we predict the demand for all product categories that we sell, and also for the most popular products, mainly for foods. This whole prediction and the whole process is fully automated. Models just run in the background. Predictions are displayed in self-service online dashboards. They can even check the key decision makers on the venue, on site at the venue through their mobile apps. Probably, before we take a look at the models and how we actually calculate these models, best to start again with the data. So the data we have, this is an example from the O2 Arena. We have over 1,100 played out events from the past 6 years with transaction level POS data. So we have every single transaction ever done at the different bars by our fans. Well, it's really granular and it's great, but what is even better, that we can just roll this up to let's say, like total. So the total spend on that night. There would be a volume problem again, because some shows are just attended by 3,000 people, others are by 20,000 people. So to get around that problem, we also use the attendance data and we calculate spend per head on the night. So for example, in total £6 or £7 was the spend per head on the night. But given the granularity of the data, we can just roll it up and aggregate on different levels. So spend per head on beer, spend per head on wine, or spend per head half an hour after the doors opened on beer, and so on and so forth. And we can just use all this information to try to predict and describe with everything what we know about the event and the fans, the ticket purchaser fans. So things what we obviously know about the event. When the doors opened, which day of the week it was on, which one we're talking about, how much was the average price of the ticket and what was the price range the ticket sold, what's the genre and the style of the show. So that's lots of information about the event, but we know even more about our fans, our ticket purchaser fans. So as we discussed previously, demographics, lifestyle characteristics, ticket purchases, and digital interactions. So I'm going to detour here for just 2 minutes and address digital interactions again. So it's a really vast and wide and rich data set that needs to be leveraged to be able to really drive the models. So another way, we discussed the similarities concept. Another way we can leverage these interactions is dimension reduction. So it would be really hard to include thousands of performers and artists in our models. So we start again with this 1-0 matrix, what we discussed previously, fun performer matrix. But this time, we calculate singular value decomposition. With the help of singular value decomposition, we calculate 50 components of all of that performer information. So what does that mean? We just reduce it to a manageable number so we can include these components in our models. If you're not familiar with SVD, probably the best way to illustrate this in this particular example is that component 1 going to be probably mean that rock style, so preference or a value in rock. Component 2 would be probably pop. Component 3 in kids shows, and so on and so forth. It's not that black and white, but that's a sort of an intuitive interpretation of these components. And we can just roll up the ticket purchaser values, take the average, and we got event level SVD components. We also have Facebook likes, Facebook page likes. So this is not available for millions of customers, only for a handful of customers who gave their consent and shared their page likes with us. But when we roll up this to event level, every single show has about 30, 50 ticket purchasers who shared their Facebook likes with us. And if you include and if you run the SVD and include these components into your model, in your model, that's going to increase again your precision. So Facebook data is really, really useful data to add that to any sort of modeling exercise, because it clearly shows behavior and preference of the fans. So how we put together our models? Altogether, there are the input variables on the right. 734 variables goes into every single model, and we predict 400 over 400 variables. So these variables, as I mentioned earlier, so spend per head on draft beer, or spirits, or hot dog, and pizza margherita. But we can do a breakdown by bars, really helping the operation. Spend per head on draft beer in the VIP lounge. And we can make a breakdown by time. Spend per head on draft beer or wine half an hour after the doors open. So we can predict all these models. We use generalized linear models with leave one out cross-validation and a 1,000-fold model average. And once the model is run, we can calculate predictions for upcoming events. I'm going to pause here for a second and just probably ask a question from the audience. So the next slide is a prediction about white wine spent per head across a few events in the last 2 quarters at the O2 Arena. I'm going to ask you that please put your hand up when you think that that given artist was probably the highest in white wine consumption. So the 3 artists are Harry Styles. He's like a pop idol, if you're not familiar with him. Kylie Minogue, a pop diva. And Iron Maiden, a metal band. So out of these, the question is simple. Out of these, which one sold the most white wine per head? So I'm gonna, tell now, and please put your hands up. So please put your hands up if you think it was the Harry Styles show. 1, 2, 3, 4. Okay, so that's a minority. Okay, so if it was Kylie Minogue, yeah. And if it was Iron Maiden, yeah. Okay. So I think you guys have probably better industry knowledge than I had before I started, my career in live entertainment. What is really great, that I bit simplified now the question, just which one was the top. Obviously, with the help of models, with the predictions from the models, you will see that, Kylie Minogue is top. That's an audience who drinks white wine. But you can also tell that how much more they drink than Harry Styles or Iron Maiden. And you can, get a better sense of Iron Maiden is below or Harry Styles or above. So instantly, I think the order, what we got here is wrong because I think Iron Maiden got more votes than Harry Styles. So that's what the models say. And what is great, so thank you so much for participating in this little predictive exercise. So that's what the models predicted, and what is great that we store these predictions before the events were played out, so we can compare it to fact values. So that were the actuals. We were quite pleased with this precision of the predictions. And we were really prepared with all the white wine on Kylie Minogue. So Iron Maiden fans, if anyone wonders and wouldn't know the answer, they drink beer. So as I said earlier, all these predictions are available through self-service dashboards on desktop or on the app, so they can check on the go as well when they on site. And it's all really great that we have these predictions, and we can be very confident that these are right on target and really precise. But there's this question of, okay, does it add really to the bottom line? It's a really hard question to answer. One way we try to answer it that we give predictions in the last quarter. I mean, in the first quarter of last year, 2017 Q1. Only for a handful of events. We call them focus events. So we give these predictions to the stakeholders for this handful of events. And and just compare the results, taking as a baseline, compare the results to the financial forecast. It was a really great quarter. Results were above financial targets, but was even more reassuring that those events where we provided the predictions performed even better. So that was about selling seats and pushing pints. But before I finish, I would like to share some ideas of what I think about what is really key to successful analytics-driven operations. So how we do at AEG. Starting from a technical side, we have a really stable and reliable technical background. So no data outages, which is pretty standard, or should be pretty standard, but it's really essential. Quick loading of data. So we're not just talking about fixing a new pipeline of some website, but when we have a new venue or just install a Wi-Fi throughout the venue, that data will just flow in very soon into our databases. Automation of everything. Everything is automated, and particularly the results from predictive exercises and analytic exercises. So there is no manual running of any models. Everything is productionized and just is put on the server and just runs overnight. Likewise, the KPIs and all metrics are fully automatically available through self-service dashboards. So we never fulfill ad hoc requests on random reports. Everything is put into self-service dashboards, saving lots of resources for the data team. And that's the technical side, but there is an organizational or human element to it as well. We have the sponsorship of the top management. They really know what we do, and they really support of it, and they want to see more of it. This is great. We always had a strict focus on business objectives, so we don't do analytics data just for the sake of analytics and data. Everything is closely tied to the business objectives we have at the company. And we have a really close cooperation, day-to-day cooperation with all the business stakeholders. Also really important. And just based on my experience, what is also super good, that everyone related to working with data sits in a single team. So there are no different silos, no bottlenecks, no lengthy processes of understanding what we really want to do. We just all sit together as one team, and we just in control of all data initiatives. At AEG, we still sit within the IT. So that was how we do, how we sell seats and push pints at AEG. And I'm really eager to hear your questions, so please go ahead. Thank you.
Thank you so much, Ákos. And yes, we have some time for a couple of questions, so we will just go from the top-rated ones. So,
what influence did GDPR have on your processes, right? That was the first question.
Yes, absolutely.
Okay. Upvoted 18 times. Hot topic, GDPR. So I think, I wasn't fully involved in the GDPR and how this plays out. All what I, as an analyst and data analytics manager, all I noticed is that suddenly I didn't have any more access to any personal information data on our customers. So we really started to safeguard the data, and all the internal processes are following the GDPR guidelines. Who has access to what sort of data. And also, from an external point of view, everything, so the whole privacy policy of all the venues and festivals we organize got updated. And if you ever, on our website at the0.2.co.uk or other websites of us, and read through the privacy policy, It's very interesting. It's quite a long read, but you can find a quite long part about everything what I just explained. So how we make automated decision making at the company, what data we use, how this company feeds into all the models, and how we join all the customer data together. So this is I think from an analytical point of view and from really like how we operate as a data team, it did not really change the essence, but everything is probably even better documented, and the data is even better safeguarded.
Thank you so much. So you mentioned that your ML pipeline is automated. How do you evaluate / debug your ML models without human aid?
Yeah, so when we build the models, so when the models are built, every time there is a test sample put aside, and from these targeted emails. So if on the test sample there's a metric called area under curve, or AUC, which shows the area under the ROC curve. If it does not reach 0.78, or the stepwise process just stopped at the first 5 steps, so these are both backstop rules, then the target groups are not saved and emails are not sent out. So that's the validation bit. I hope that makes sense. It was a bit technical, but I hope that answers the question.
Thanks. Where do you get all this data from the fans, like income and spend of holiday? Easy black market.
Yeah, so in the United Kingdom, it's pretty industry standard that there are third-party data providers. So as I said, we have operations in the UK, Germany, France, and Sweden. So these variables this information is not available there. But on the UK market, you can purchase this from a third-party data provider. Some things they do know exactly. Some other things they also use models, like calculating the income of a customer. So all these data, all these data are really interesting and nice, but to be fair, in the models, these are really hardly anytime selected. It's really the behavior and preference data that drives these models. So demographics, you've seen these at other industries as well. Demographics is nice and great, but when you have digital interaction data, so that reflects behavior and preference, then it's just way better, more useful and more valuable.
Thank you. Do you sometimes fool or trick out the customers, like selling tickets at a higher price because of knowing their profiles?
No. No, it's no,
loud and clear.
So our industry and AEG and other big players are really with the fans. So there is I don't know if you heard about the secondary market and resale of tickets on different providers like StubHub and Viagogo and all these websites. So they are the ones who really just try to make some extra profit selling tickets at extra prices. But for us, we usually now what became the standard practice, that we put the name of the ticket purchaser on the tickets, and to really prevent to resell the tickets, and it shouldn't be touts profiting from selling tickets. It should be about fan experience and people going out and visiting the shows. So yeah, definitely not.
It's not Ryanair right here, right? How do you train, validate, and test a logistic regression model with 200 input variables?
Train, validate, test. So it's stepwise regression. Yeah, there is a. So so the question was probably, so there are for the logistic regression model, so those run for selling tickets. So there is just a simple entry and exit looking at the statistics of the variables, if they can enter the model or just they dropped out. So nothing too crazy.
Okay, maybe one last question, real quick. How do you deal with sparse data? For example, customers where you only have an email address.
So, yeah, when we only have an email address, so we only have an email. If we only have an email address, that means that they sign up to receive newsletter or sign up to pre-sales of some show, or they purchase the tickets for a show. So that's not just only email address. That's already a data on behavior. So yeah, and then when they return, we have